Hello everyone, welcome to this lecture. In today's lecture, we're going to introduce arrays. So arrays are basically fundamental data structures in C++ and any programming languages. And they are important because they allow us to store multiple elements of the same time in a single block of memory. So let me give you an example. So we would like to write a program to store 5 numbers in an array and then print them. In order to do that, previously we know from the integer data type we could simply just declare and initialize one number, two numbers, three numbers, four numbers, but they were initialized and declared separately. Here, using arrays, we can do them, we can do it and like declare all of these numbers in a single block of memory. How we are going to do it? Okay, so this is how we declare and initialize an array. So this is the name of the array, which is numbers. This is the size of the array, meaning that this array is having 5 elements, and then this is the data type of the array, which is integer. And when we want to declare and initialize an array, we're going to say that, for example, the data type, in this case int, numbers, the name, and within the bracket we put the number of element of the array, and then equals, and then we write down the element itself. So previously we used to write it something like int a equals 10, for example, int b equals 20, for example, etc. And when we wanted to print them, we were printing them separately. We were just typing it like the value of a is, for example, a and l. So this way we were printing a, and the same way we were printing b, for example. Here we write down b, here we write down b. So this was the old method that we used to print elements and declare and initialize them. However, using an array, we can just declare and initialize all of them in a single block of memory, just like this line. Okay, so we would like to write a program to store 5 numbers in an array. That we did, and print them. In order to print an array, because there are multiple elements in the array, we need to use the for loops. So in order to use the for loops, we are going to iterate over each element of the array and print them one by one. Let me explain you in the code. So we say the numbers in the array are, and then we go to the next line. Then we have our for loops here. So int I equals 0. It starts from 0 and it goes to 5 because we have 5 numbers, 5 elements in this array. And then we increment the value of I one by one. Then we see out numbers, which is the name of the array. Within the bracket we mentioned the I because it's going to print the first time. Let me just type it down here. In the first iteration, I equals 0, and it enters the loop. Then we have the numbers 0, so it will be printing the first element of the array number. When it is printed, it goes back up and I is incremented by 1 value. Then I now equals 1. Then it comes back and enter the loops and it will print the numbers 1. And the second element, because in here we are starting from 0, now 1 equals the second element of the array. It is going to print the second element of the array, and then it goes back up again and I is incremented by 1 value. Now I equals 2. When I equals 2, we are having the numbers and the third element of the number. So the first element of the array number equals 10. So in the first iteration, we are printing 10. In the second iteration, we are printing 20. In the third iteration, we are printing 30. And it continues until we have numbers 3, it equals 40. And finally, numbers 4 equals 50. So please note that we started from 0. So this is why we are ending at 4. But all in all, you will see that 5 elements are being printed here. Therefore, all of the elements of the array is expected to be printed. Let me run the code and see how it works. Okay, great. So as we can see here, the numbers in the array are, so this line is printed, then it is printing 10, 20, 30, 40, and why there is a space between them. The reason that there is a space between them is that because when we are printing the element, the ith element of array number, we are having one space here. So this is why we are seeing that 10 and then space 20 space 30 space 40 space 50. So this is why we are having this space. So to summarize, we learned that we can have we can have an array to store multiple elements of the same type in a single block of memory like this. And when we are going to print elements of an array, we need to use for loops to do that. And why we need the for loops? Because there are many elements. There might be several elements, a few elements in an array, so it's not a single element. There are a few elements that if we want to have an efficient code, we can just iterate over each one of the elements and then print them instead of just manually printing them one by one. Thank you for watching. In next videos, we're going to do some coding exercises regarding the arrays. Hello everyone, welcome back. In today's video, we are going to do some coding exercises for the arrays. So we would like to write a program to find the largest number in an array of 5 integers. First, we learn that how to declare and initialize an array. Here we need to declare and initialize an array with 5 elements. So the elements should be integers. So we know that in the declaration we write down int, then the name, and then 5 elements, and we just randomly put some numbers, 5 elements for the array, and then we need to know how to find the largest number in this array. To do that, initially we initialize one integer as to be the first element, as to be equal to the first element of an array. This is just an assumption. We are going to first assign the first element of an array to this max integer initially, and then we are going to perform some tasks on and some iteration over the different elements of the array, and then we are comparing each element of the array with this max integer. So if a number in an array, if an element in an array is larger than this max value, we are going to assign that number to max. To do that, we need a for loop. So here we declare and initialize the array. Then we are initializing the max to be the first element of the array. This is just an assumption. We can put it to be like the second element, the last element. This is just an assumption to start from somewhere. Then, in order to find the maximum element in the array, we are going to have a for loop. So we are going to have a for loop that is int I equals 1, I lower than 5, I plus plus. And because already the first element is assigned to the max, we are not going to iterate over that. We could do it, but it's redundant because already we know that the first element equals max, so we're not going to iterate over that. So this is why we suggest to assume that max equals the first element. However, you can iterate over all of the elements and assume that max equals any of the elements. It's okay. So we are iterating from the second element till the end, and we are defining an if condition here. We are saying that if the element I of the array number is larger than the value stored in integer max, if this is true, enter this condition and assign that value to our max integer. So for example, let me just explain how it works. So initially max equals 45, and then for the first time when we enter this loop, we have the numbers 1, okay, which equals 12. And in this situation, when I equals 1, we have numbers 1. So numbers 1 means that the second element of the array numbers. And why, when we are writing down 1 here, why we are saying the second element? Because in C++ we start from 0. The first element is it's written like this: 0 element of number means the first element. Therefore, the first element, when we're writing the 1 value here, it means the second element. Okay, so it starts from 0. When it's 1, it means the second element. So it is entering the loop with I equals 1. I equals 1 when it is talking about the 1 element, the second element of the array number, it equals 12. So it is saying that 12 is 12 larger than max? No. So it's not going to enter the loop because max is already 45, so it's not going to enter this if condition. Then I value is incremented by 1 and I equals 2. When I equals 2, let me just write it down in the next line. So max still equals 45. We are discussing the third element of the array number, which is 78. So I equals 2 meaning that it is the third element of the array number, equals 78. So it says that 78 is larger than 45. Yes, it enters the condition and then assigns number 78 or the third element of array numbers to the max. So now max is updated. After implementing this part, max equals 78. Okay, then this condition is finished. We go up and we increase the value of I to be 3. So now max equals 78 numbers. So this is going to give us the fourth element of the array, which is 34. So it is basically in this condition saying that is the fourth element of array number, which equals 34, larger than the integer max, which is 78? No, it's not. Then it's not going to enter this if condition. And then max remains the same. Max remains the same, and numbers, we increment the value of I by 1, which is its max value now, because for I must be lower than 5, not lower than or equal than 5. So now I is 4. It's going to discuss the fifth element of array number, which is 56. So it is basically asking, is 56 larger than 78? No, it's not. Therefore, it's not going to enter the if else condition again. And when everything is done, so that in the next round, we are not going to enter the for loop, because now I is incremented by another 1 value. It will become 5. 5 is not lower than 5. Then it's not passing this condition and it's not going to enter this for loop anymore. In the end, it is printing the largest number in the array is max, and max equals 78 as we analyze the code. So let's run the code and see how it works. Okay, great. So here we see the largest number in the array is 78. So this is the procedure how we can find the largest value in an array. If we want to find the smallest number in an array, we simply just reverse the code and we're just putting is number lower than max, and if this condition passes, we are assigning that number if into the max. Thank you for watching. Hello everyone, welcome back. In today's lecture, we are going to do another coding exercises for arrays. We are going to write a program that takes 5 numbers as input and store them in an array. And then it calculates their average. To do that, first we initialize an array with the size 5. It is named numbers and its type is double. And in order to have an average, we first need to know their sum. So we are initializing a double sum equals to 0. It is initialized to 0. In order to get a lot of data from the user, not just one data, one input, but as large as the elements of our array, we need to use a for loop. In order to do that, we mention, okay, enter 5 numbers, and then we enter the loop I equals 0, and I, as long as I is lower than 5, we are going to iterate in this for loop again and again. And in each iteration, we are mentioning that, okay, now enter the ith element of the array. So for the first time, it's going to mention, okay, numbers 0, numbers 1, numbers 2, numbers 3, and finally numbers 4. So it is going to ask you enter 5 numbers, and then you're going to enter 5 numbers continuously, and you're separating them with the enter button. So the first number you are entering, it is going to be stored in the first element of the array number using this line. And the second number you are entering, it is going to be stored in the second element of the array number again here, because I is incremented one by one. So the first time I is 0, I enters, and then you're writing down the number 0 like this. And then I is incremented and it's now 1. Then what you're entering is stored to the second element of the array number. Then I is incremented one more time and it is 2. Now what you're entering is going to store in the third element, in the fourth element, and in the fifth element of the array number. So this is how the procedure would be when we are going to store some elements in the array. And finally, after each iteration, it is going to store the sum of these numbers. So this sum was initialized to be 0, but whatever you're entering, it is going to be added to sum. So the first time, let me just run the code once. It says enter 5 numbers. I would say 1, 2, 5, 7, 9. Okay, so we are not going to talk about this line yet. Let me just talk about the above line. Okay, now it's good. So it says enter 5 numbers. So I entered 1. 1 is now the element, the first element of the array. Now sum was originally equal to 0. We initialized it. Now 1 is added to sum. Okay, now sum is 1. Then it is asking me So they are going to be done after another, okay, one after another. So this line is going to store, and then this line right after that is going to assign the number to sum. So then I'm entering the second element, which is 2, and it's going to be stored using this line. Like we are saying that, okay, now I equals 1. I equals 1 means that it's going to store the second element, and for the second element I'm entering 2. So for the second element I'm entering 2, and sum was already 1, and now 2 is added to that one, so the sum equals 3 now. Then I increased by another value for the next round that it enters the loop. Now I equals 2, and it is what I'm entering here, like number 5, is going to be assigned to the third element of array numbers, okay, and 5 is going to be added to the already value of the sum, which is 3, because the first time was 1, the second time was 3. So sum initially it is 0, then it is 1, then it is 3, and then let me give you the details. I will write down the next steps, but when I equals 0, we are going to write down the first element of the number, and we mentioned that we have the first element equals 1. So 1 is stored as the first element of the array numbers, and 1, so initially sum equals 0, and 1 is added to sum. So now sum equals 1, okay? Then I is incremented. Now I equals 1. When I equals 1, we are going to enter the second element, which is 2. So we enter 2, the second element of the array is stored, and then 2 is added to this 1, because sum equals sum plus numbers I here. So having this equation is equal to have sum plus equal numbers I, okay? So they are the same equation, this equation and this equation. Okay, so sum was already 1. Sum was already 1, and we added the number 2 here. So sum in the next round, sum equals 3. Okay, then I equals 2, because in the next iteration I equals 2. When I equals 2, I entered number 5, which will be the third element of the array. So the third element of the array is stored as to be numbers 2. Okay, then sum was already 3. Now I'm adding sum equals 3 plus 5. So then sum becomes 8. So the next value of the sum will be 8. And then we are increasing the value of the I another time and another time until the end. So we are entering all elements, and each element is being accumulated in the sum one by one when they are added. And when everything is finished here, we are just printing the value of the average. How? We are initializing a double called average, and the sum is divided by the number of the elements of the array. In this case, it is 5. And then we are printing out the output. So based on our input here, like 1, 2, 5, 7, 9, let me just print also the value of sum here. Cout the value of sum equals, then we are printing sum here and del. So 1, 2, 5, 7, 9. Okay, let me just 1, 2, 5, 7, oops, 9. Okay. So here we are seeing that the total value of sum is 24 and the average is 4.8. And if you would like to see the increment value of sum in each iteration, I can simply print it here. So we can see how sum is incremented. 1, 2, 5, 7, 9. 1, 2, 5, 7, 9. Okay. So now we are printing the incremental value. So initially, sum was 0. Then I added 1. So sum became 1, exactly as we wrote here. Sum became 1. Then we added 2 as the second element. So the sum became 3. Then we added 5. So the sum became 8, exactly like we calculated here. So basically, we are saying sum was 0 first. We added 1 value, it became 1. We added another 2 value, it became 3. We added another 5 value, it became 8. Another 7 value, it became 15. And another 9 value, it became 24. And then this number is divided by 5, the total number of elements in the array, and the average is calculated this way. So this exercise was very easy and straightforward. However, in order for you to get used to how arrays work and how we can read the elements of an array as the input values, and then how to work with them, how to print them, how to calculate the sum and average, it would be nice for you to do some coding exercises and start implementing these coding exercises that I have solved so far, so you can first master the basics of an array before we move to further exercises. Thank you for watching. Everyone, welcome to another lesson. In today's video, we are going to learn how to integrate arrays and functions. So we know that in order to reduce the amount of repeated information in the code, we need to write functions. So simply in the int main function, we call another function or many other functions that do certain things for us instead of just repeating those operations in the main body of the code. To do that, we use functions. So for example, if we would like to know the sum of a few numbers, we can define a function that does the sum of two numbers, for example, for us. And every time we call the function, it is going to give us the sum of those two numbers. So this would help us to write down the operations to do the summation only once. However, we can call it several times instead of writing the summation operations several times in the main code. So this is why we actually need to write the functions. For example, here is a void function that we have here. And simply we are just calling the function and everything done, everything else is taken care of. So in this section, we are going to pass an array as an argument to a function, and the function is going to do some operations with this. So what is the operation? We are asked to write a program that prints all the elements of an array using a function. So the statement itself says that, okay, print all the elements using a function. So don't do it in the int main function, but define a separate function. In order for you to review the basics of functions, there are three things that we need to take care of when we are looking at a function. So the first one is the name. Behind the name, it's the type of the function. So it's a void function. It can be int function, float function, double function. But when it's a void function, it is not going to return anything. If it's a function of any other kind, for example, here we have an int, we're going to return some value. If it's a float or whatever, there is a return value to be passed, but for a void function, we have no output. It's just going to do certain tasks for us, or maybe print something for us, and that's it. So first thing is the name, then the type of the function, and in the parentheses we have the arguments of the function that are separated with a comma. So we would like to write a function that takes one array and it's going to print the array. To do that, we declare and initialize the array like this. We learned it before. So we are saying that the name of the array is numbers and the type of the array is int. However, the size of the array is not indicated, but it's okay. I could tell 5, it's okay. But even if I don't tell it that the size of the array is 5, it can determine it itself because there are 5 elements in this array. So it's up to you. You can write it down, or it's okay if you want to escape it. Then we need to know the size of the array. So there is a predefined expression in C++ that gives us the size of the array, or of one element, one integer, etc. And it's the size of. So using this, we calculate the size of this array. How to do it? This is a formula. So we initialize one integer called size, and we divide the size of the array by the size of the first element. Why do we do that? So by doing this, for example, we are having an array of 5 elements, and when we are calculating the size of the full array, and each element is going to, for example, take 4 bytes of the memory. When we have 5 elements, it's going to take 20 bytes. And then when we divide it by one of the elements, we are going to understand how many elements it's having. For example, assume that each element is consuming 4 bytes of memory. So when we have 5 elements, it's going to have 5 times 4, it's going to have 20. It is going to consume 20 bytes of memory. So on top we have the number 20, and it is divided by the size of element 1, which is 4. Then 20 divided by 4, the result would be 5, which is the number of elements in the array. So this is how we are calculating the number of elements in one array. The total size, the total bytes that are using the memory, divided by the first one, or any of them, like the second one, the third one, because they are going to take the same amount of memory, each of the elements. So this way we are calculating the number of elements, okay? And we assign it to size. Then we are calling a function, and we are passing 2 arguments. Why 2 arguments? Because this function is defined and initialized with 2 arguments. The first element is the array. The first argument is the array, and the second argument is the size of the array. So here we are passing as the first argument, we are passing the array itself and then its size. Okay, we are calling the function. We go up here and we enter the function. It is getting the array and its size. So it is counting, printing array elements are. Then in order to print all the elements of an array, we need to iterate over all the elements. To do that, it's easy to use for loops. So we are going to use a for loop, but why do we need the size? Because we would like to automate things. Because of that, we can mention, okay, it's going to start from 0 as the first element of the array, and it is going to go up to the size of the array. Okay, so this is why we need the size. And then we are going to increase the value of I one by one. To do that, let me run the code once so we see the result, and then we continue with analyzing the code. Okay, great. So here it is saying that array elements are 10, 20, 30, 40, and 50. It's printing everything. So this is what we wanted. And there is one space between these, each of the elements. That space comes from here. So let's start by analyzing the code again. So the first time that we entered the array, we entered the for loops, sorry, I equals 0. When I equals 0, it is going to print the first element of the array using this line, ARR, ith element of the array. In this case, because I equals 0 and C++ starts from 0 basically, and we are here starting from 0, therefore it is going to print the first element of the array. And the first element of the array is 10. Okay? Then it's going to go up again. We increase the value of I by 1. So I is now equal to 1. And then we are going to print the second element of the array, which is 20. And then again, it goes up again and increase the value of I by 1 value. So now this time we enter the loop I equals 2, and we are going to print the third element of the array, which is 30, etc. until the end. So this is exactly what we got as the output here. So basically, instead of doing all of these tasks in the main function, we are just simply calling a function that does this for us. So our int main function remains very clean. So this is the first thing. And the second thing I would like to highlight is the size. So we learned how to calculate the size of an array. So now we know if we have an array of 10 elements, we know how to calculate the number of elements in that array. This is one thing. And the second thing is that we passed the size instead of, calculating, this array is having 5 elements. So instead of writing size, I'm going to write 5. Instead of doing this, we automated things. So the size is simply replaced here. Why? Because every time that you're dealing with an array and you're calling the function, you don't have to change this number anymore. So because you may have another array with the size of 3, 10, 15, etc. So you're automating things, whatever the size is, the function is going to work instead of just manually changing the size here. Thank you for watching. In the next video, we are going to do another coding exercise using functions and arrays. Hello everyone, welcome back. In today's video, we are going to code another exercise, and in today's lesson, we would like to write a function that count the number of even and odd numbers in an array. So we need to write a function that in the end iterates over all the elements of a function and tell us how many odd numbers and how many even numbers are included in that array. To do that, we need a function to make the code very clean. So we start with the int main function. We initialize one array. By now we know how to declare and initialize an array. Then we calculate the size. In order to calculate the size of an array, we calculate the size of the array divided by the size of the first element. So this way we know how many elements are included in this array. And then in order to count the number of even and odd numbers, we just declare two new integers like even count and odd count. So then we call our function and we are passing 4 arguments. The first one is the array, the second one is the size of the array, and the third and the fourth ones are the integers that we declared here, that they are going to do the counting for us, to count the number of even numbers and odd numbers in this array. So let's go up here. When we call the function, we are coming up here. The name of the function is here. It's a void type. In the parentheses, we see the arguments. We see 4 arguments here separated by comma. So the first one is the array of type int. The second one is the size of the array by type int. The third one and fourth one also they are type int. However, they are passed by reference. So let me review the concept of passed by value and passed by reference one time here. So you see these two values are passed by value because there is no and sign behind them, before them. It's a passed by value. So basically in passed by value, we are making a copy of the original numbers or arrays, and we send the copy of them to the function and let the function to work with the copy. So any modification that is made to the array or the size integer is going to be locally implemented here, and it's not going to have any impact in the array and the size in the main function, because this function is working with a copy of the original value because it's a call by value. Okay. However, when we are doing the call by reference and the sign is having this and behind the before the name of the integers, we are calling by reference, and calling by reference means that we are giving the address where these two values are stored in the memory, and it is going and directly working with the original values. Therefore, it is making modifications to these values. So any changes that are done here is going to impact on these two. So this is the basic concept of call by reference and call by value, and why we are passing these two why we are passing these two arguments using call by reference, because this function is actually going to count the number of even and odd numbers for us. Therefore, it's important to know the output value in this main function as well. This is why we need a call by reference. But for the first two values, we don't need any output from this function for these two arguments. Therefore, we are just calling by value. Okay, now that we know the difference between call by reference and call by value, we are initializing these two past numbers to 0 because they were only declared and they were not initialized. We are initializing them here. In order to iterate over all the elements of an array, we need to use for loops. So we start from 0 and we go up to the size. This we know from before, and we are increasing the value of I one by one. So we are going through all the elements one by one. And then in order to see if a number is odd or even, we need to define if-else conditions. To do that, we say if the ith element of array is divided by 2 and its remainder, using modulo sign here, and its remainder equals 0, it means the number is even. Therefore, increase the value of even count by 1 because we found one even number. And if this condition is not going to pass, go to the else, because if the number is not even, it is for sure an odd number, and increase the odd. Okay, let me make some further analyze of the code here, so it would be easier to follow. So we are starting to we start to go through all the elements of the array here. And the first one is 10. So I equals 0, we enter the loop. Here I equals 0, we enter the loop. And it is investigating to see if the first element, the ith element of the array, which is the first one in this case, because I equals 0, if this number is divided by 2, its remainder equals 0 or not. The first element of the array is 10. So 10 divided by 2, the remainder will be 0. Yes? So the remainder equals 0. Therefore, it's an even number. So we say even count equals 1 now. Then, when this condition is passed, we are going up again, and now I equals 1. Therefore, we are investigating the second element of the array. So we are saying that basically we are entering with I equals 1. We are basically discussing array in the bracket 1, which is the second element of the array, which is 15. And we are basically saying that if 15 is divided by 2, its remainder equals to 0 or not in this line. Okay? We are saying that 15 divided by 2, the remainder equals 0? No. When the answer is no, it's not going to enter to this part. It's going to escape because it's not passing the condition. Therefore, it is going to enter the else part, and it is increasing the value of odd count equals 1 now. And now that it's done, we go up again, we increase the value of I one more time, because it is going to iterate until I is lower than the size of the array. And the size of the array is 1, 2, 3, 4, 5, 6, 7. So I is going to take from 0 to 6. So I equals 2, and then we are discussing the third element of the array. So the third element is 20. We are basically in this condition discussing if 20 is divided by 2, the remainder will be equal to 0. Yes? Yes, this is true, because 20, if it's divided by 2, the output will be 10 and the remainder is 0. Therefore, we are going to increase the value of the even count another time. So this time it is equal to, because previously it was 1, and then we are increasing another time in this line, so it equals to. Okay, now I equals 3. We are basically discussing the fourth element of the array. So the fourth element is 25. I equals 3, it enters, it says that ARR in the bracket number 3, which is the fourth element of the array. If it's divided by 2, its remainder equals to 0 or not. So here basically 25, if it's divided by 2, the remainder is not going to be equal to 0. Therefore, it's not going to enter this condition, and it's going to enter else. And when it enters else, it's going to increase the odd count integer by another 1 value. So odd count, previously we had it here, it was equal to 1. And now it is we are going to add another 1 number to it. So it is going to equal to 2. So basically this is the logic of the code. Now if I run, you will see how many odd and even numbers we have in this array. So basically 1, 2, 3, and 4 even numbers are included in this array, and we have 3 odd numbers in this array. So let's run. Okay, great. We see exactly like the number of even numbers and number of odd numbers. Okay, so here we do all of the calculation, that we call the function here, and we do all of the calculation here. After everything is finished, we are coming back to the main function, of course, and we are going to print number of even numbers, or we are printing the even count, and number of odd numbers, we are going to print odd count. Okay, And we see that the number of even numbers is 4 equals to 4 and odd numbers equals to 3. This is what we expected actually. And the important thing, just to summarize and highlight, is to do this by calling by reference, because these two numbers are going to change here. We are actually calculating their value one by one. Here we are incrementing their value, and then we are printing the final value that we got here in the main function. So if it's a call by value, it's not going to have the output the correct number, because it's not going to change. When the function is finished, it's finished and everything else is deleted. Thank you for watching. Please make sure that you do these coding exercises yourself, because it's very important. They may seem and they may look easy and understandable, but you will never make errors until you do it yourself. So please do go ahead and do it yourself. Please make errors, because it's important to know where the errors come from, and then you can improve from there. And you can always come back to these videos and review the logic and analyzing the code, so you will find exactly how you need to improve your coding. Thank you for watching. Hello everyone, welcome back to another coding exercise session. In today's video, we are going to do coding exercises with respect to the arrays and functions. So we would like to write a program that checks whether a given number exists in an array using a function. So basically what we understand from this statement is that we need to write a function that checks if a given number exists as one element of the array or not. So to do that, we have the int main function here. We are initializing and declaring one array. We know from before how to do it. Then we are calculating its size to see how many elements this array is carrying. In this case, it's going to be 5. And then we are initializing the target, we are declaring the target integer, which is the given number that is going to either be decided that its number is it included in this array or not. So this target is going to be read from the user. Like I'm going to enter like one number, as for example 7, and we need a function to see if this number 7 is included in this array or not. Is it one of the elements of this array or not? So this function is basically going to do that. So we initialize the target integer, and we are sending a message to the user saying that enter a number to search, and then we are storing it using a scene syntax. And basically we are checking here if search element, the search element is the function that we define to do the checking for us, and we are passing three values, three arguments. First the array, second the size, and third the target number. So we are simply here, we are saying that if something is true here, just print that we found that number, that target number in the array. Otherwise, print that it's not in the array. From this if condition, we understand that this function is having is of a Boolean type. Why? Because we are saying that if this statement is returning true, go ahead and print the target number and mention that it is found in the array. Otherwise, say that this target number is not included in the array. So let's go and see how we are doing this calculation using search element function. When we call the function here, we go up with three arguments: array, its size, and the input target number by the user. We go up here And we see that the type of the function, as we discussed, it's a Boolean. So it's going to return something for us. It's going to return either true or false. Basically, we can guess. So if the target integer is one of the elements of the array, it's going to return true. If the element is found in the array, it is going to return true, and otherwise it's going to return false. So when it is going to return true, it's going to print that the target number is found in the array, and when it's going to return false, it's going to mention that target number is not in the array. So basically, this function, this is the name, this is the type, which is Boolean, and these are the arguments of the function that are separated using commas. So the first one is the array, the second one is the size of the array, and the third one is the target number. And all of them are passed by value because we are not going to make any modification to them. We're just going to work with their values. This is why we're not calling them by reference. So in order to see if one one integer is actually equal to one of the elements of the array, we need to iterate over all the elements of the array to see if one of them matches this target number. To do that, we use a for loop to iterate over all the elements of the array. So we start from 0 and we go up to the size of the array, which is 5 in this case. And one by one, when we are passing through, we are saying that, okay, is this element equal, is this target number equals to element ith of that array? So let me just analyze the code further. It's more clear for you to understand. So let me just mention that, for example, I choose the target number to be like 18. Okay, so I would say target equals 18. So when target equals 18, initially I equals 0 and it's going to enter the for loop. So when I equals 0, it is going to investigate whether the first element of the array equals target or not. And this means that we are checking to see if 5 equals 18. How? So I chose 18 to be the integer target, I equals 0, and when I equals 0, when we are investigating this condition, we are basically investigating this. So the first element of the array, is it equal to the target number? And basically it means that the first element of the array is 5 and the target equals 18. Therefore, we are mentioning if 5 equals 18. So if this is the case, it is going to return true. So it is existing. It exists, and it's going to return true here. And then we are getting out of the loop, and we are simply printing that, okay, the target number is found in the array. But in this case, this is not the case for us, okay? So as this is not the case, target is still 18 because we are not going to change it. It's a one-time chosen value. Then it is going to investigate I equals 1, which happens to be something like this. So when I equals 1, we are simply saying that, okay, the second element of the array equals to target or not. In this condition, we are investigating this. And since the second element of the array is 10, we are basically investigating if 10 equals 18 or not. This is not true, okay? So when it is not true, again, it is going up and increasing the value of I by another of I by another one value. So now I equals 2, which means that we are going to investigate the third element of the array. So when we are investigating the third element of the array, we are basically mentioning, is 15 equal 18? No, it's not true again. So it's going to go to another round of the loop. This time, again, target is 18, I equals 3, and it means that we are investigating uh, the fourth element of the array, meaning that we are saying, does 20 equal 18? No. And then for the last time, we are going to increase the value of I another time. So I equals 4 now. And then we are discussing the fifth element of the array, and we are basically saying, is 25 and 18, are these two numbers are equal? No, we didn't find any answer to return true because neither of these equations are correct. So it's not going to enter this if condition. When it's not going to enter this if condition, it's not going to return true. And then when it is exiting this condition and this for loop is finished because we reached its upper limit, which is 4. Why? Because when I is 4, it is lower than the size of the array, which is 5. So 4 lower than 5. When we are increasing the value of I another time, I becomes 5, then 5 is not lower than 5, therefore it's not going to do another for loop. So we exit here and we are simply saying that, okay, return false because we didn't find it. So basically, let me run the code and enter the target 18. We are expecting to see 18 is not in the array. So let me run. So enter to search, I'm saying 18. Okay, it is saying 18 is not in the array. Okay, so and how it is deciding whether it's in the array or not, using these analyzes, we are understanding it. But what if we are mentioning number like 10 as the target value? If we mention the number 10 as the target value, so let me just revise these numbers. Okay. So if the target value is 10, I starts from 0. It is comparing the first element of the array, which is 5, with the target number, which is 10 now. And we are saying, okay, does these two numbers are equal or not? These two numbers are equal or not? So it's no, the answer is no. Therefore, we are going up again in the for loop statement and we are increasing the value of I by another one value. So I equals 1 now because it starts from 0. Okay, I equals 1. So we are basically, when we are investigating this condition, we are basically saying that we would like to see if the second element of the array equals to the target value, which is 10. Basically, we are saying, does 10 equal 10? Yes, the answer is yes. When this makes sense, when this condition makes sense, it actually enters this condition to return true. When it returns true, the work of the function is done, it's finished. And here it is simply mentioning that, okay, target value is found in the array. So because when it returns true, this if statement becomes true, and then it enters this part, and when it enters this part, it's going to print it. So let me just choose the input target value to be 10. Okay, it says that 10 is found in the array. So basically, this is how we did the coding exercise and we analyze the code, it would be nice for you also to start doing these analyses for yourself to make sure you understand all the steps one by one. This helps you to remember how the program works, and it will be beneficial for you in the future. When you are writing your code, you can imagine, okay, if I write it this way, it's going to work this way. So this is what we want, or this is not what we want. So I'm going to change or modify the path, etc. So please go ahead and do this exercise yourself, because as we progress, there are many coding exercises that we are going to do. So try to start the coding exercises and do the coding exercises yourself as you proceed throughout this journey. Thank you for watching. Hello everyone, welcome to another video. In today's lesson, we are going to declare and initialize one array, and we are going to do some simple manipulation that are important using an array. So basically, we know how to declare and initialize an array. So the name of the array is x of size 5 and it is of type integer. And there are 5 elements in this array: 1, 5, 8, 12, and 15. In order to print the array, let me just comment the rest of the code. So in order to print the array, we do it using a for loop. We start from 0, we go up to the size of the array, and then we are printing the ith element of x. So first time I is 0, then 1, 2, 3, 4, and all the elements of the array is printed. Okay, great. So this we know from before. I equals 0. When I equals 0, it's like this: x 0, then I equals 1, x 1. So when x is 0, it's going to print the first element of the array like this. Then when I equals 1, it's going to print the second element of the array x, which is 5, etc. So we know how to do this. This is just to show you how we print the elements of the array. But if we would like to print specifically one element of the array, we can simply do something like this. So we name the array, and then we are going to call the uh, element of the array that is in braces. So in the braces, we are saying 0. It means that call the first element of the array. Then we are having in the braces, we have the number 1, which is going to call the second element of the array, and then the third, then the fourth, and the fifth elements of the array. So this way we also can print the elements of the array. But if we are only willing to print for example, the fourth element of the array, so the fourth element of the array is this one, because C++ starts from 0. So this is the first element, second, third, and the fourth element of the array is x, the name of the array, and in braces we type down the number 3. So it's going now to print us the fourth element of the array, which is 12. Okay, so this is another point. These are very basic operations, but I think it's important to know them before we dive into more advanced parts of the array. So basically, we can manipulate array elements. So initially, the first element of the array was equal to 1. Here, I'm assigning number 10 to be the first element of the array. So if I print again the array, we will see. Let me just print also the array here. Okay. So, yeah. So we see that when we initialized the array, the elements were like 1, 5, 8, 12, 15. We printed it. It is here. It is printed here. Then using a line, we are trying to separate them from here. And then we assigned 10 to be the first element of the array and using this line. And as you see, instead of having 1, we are having 10 here. But the other elements remain the same. So we could assign it to the second element, for example. Okay? So when we are assigning it to the second element, the first element is the same. The second element, instead of being 5, it's 10 now. We could also manipulate more elements like x equals like 68, for example. Okay, the fourth element. So in this case, we are changing two elements. The first element is the same in both arrays. The second element was 5 initially here, was 5, and now it's 10 because we assigned 10 to the first element. The third elements are the same. The fourth element, initially it was 12. Now then we set it to be 68, and the last elements are the same. So this way we can also manipulate the elements of an array manually. And the next interesting thing that we can do is the following. So we can initialize one integer called index to be 0. Instead of writing x within braces 0 equals 26, instead of writing this like above, we mentioned the example, we can write it like this. It's nicer to write it like this. So we, instead of within the braces, instead of writing the actual number 0, we can define an integer that is 0, and then we put the index integer in the braces. So this way we are also able to manipulate the array. So let's see. As you see, the first element was initially 1 and now it's 26 because 26 is assigned to the index element of the array x, and index equals 0. Therefore, the first element of array x equals 26 now, and we are printing the value of index in the end to know the value of the x. So let's do some further modifications here also. So here I am writing down that index the index was 0, right? And we printed it, it's 0. Here index is 0. So if I again type x index equal 91, it's going to, because x was 0, index was 0, it's going to put 95 to be the first element of x. However, using this line, we are first increasing the value of index by 1. So index was 0, now it becomes 1. And then 91 is assigned to the second element of the array x. Let's run and see. Okay. So the first array, the second array is this one. So the first element of the array is set to 26, and the remaining elements are the same. We know it from here. However, when we are increasing the value of index first using plus plus, and then we write down the index in the braces, it is going to first increase index from 0, which was here to 1, and then 91 is assigned to the second element of x. It is something like this now, equals 91. Okay, because now index becomes 1. So this line is exactly like this line, because index was 0. We increase 0 by 1 value, so it becomes 1. In the braces it becomes 1, and when it becomes 1, it means the second element of the array x. So when we are talking about the second element of the array x, 91 is assigned to it. So either writing this line or this line, they are going to do the same thing. And here, when we print again the index, we see that the index equals 1 because we increased its value. However, if the plus plus is after the index, this is interesting. So if plus plus is after the index, so we see the second array was 26, was set for the first element. So we know from before, and index is 0. But when the plus plus is after index, it means that 91 is assigned to the index element of the array x. And in this case, index equals 0. So when it simply means x0 equals 91. So this line equals this line. However, when 91 is assigned to the first element of the array x, afterwards, the index value is increased by 1. You see? So when we have the index, after that we have plus plus, it means that 91 is going to set to the indexed element of the array x, and in this case index is 0. Okay, 91 is going to assign to the first element of the array x. When the assignment is done, then increase the value of index by 1. So this is why we are seeing that the index value is 1, however 91 is assigned to the first element. So it's important to know where to put the plus plus depending on what we expect it to be. So let me just keep it afterwards. So 91 is going to assign to the first element of the array x, and then index is going to increase by 1 value, so index becomes 1. Let's do the last example here. When we are doing the last example here, okay, let's go up and review everything. So we initialized one array, we're printing the array, and this is the original array. Then we are changing the first element of this array. We initialize index to be 0. Then we say that the first element of the array x equals 26, and then we print the array. We print the array, we see that both arrays are having the same last 4 elements, but the first element is modified because of this line. And this line equals this line exactly because index equals 0. And then we print the value of index, it's 0. Then we are mentioning that, okay, now index is 0. Therefore, assign 91 to be the first element of the array x. Why first element? Because index is 0, it's going to assign it to the first element. When the assignment of 91 to the first element of array x is done, then increase the value of index by 1 using these two plus plus sign. So 91 and then we print the array. So this way 91 is assigned to the first element of the array. We see that it is modified from 26 to 91. But when we are printing the value of index, it's going to print value 1. And in the end, since index now equals 1, when we are writing this line, it means that put the 68 to be the index element of the array X, and index equals 1. Therefore, it's going to set 68 to the second element of the array X, and then it's going to print, the array. It's going to print the array. So we see that the 91 stays the same, but 68 is here as the second element of the array, and index equals 1. So this was a very good coding session, I think, because there are simple things, simple manipulation that we are going to do in later lectures. However, this lecture is a basic for manipulating the different elements of an array and working with plus plus index or index plus plus. So these are important to know a priori to solving further advanced example. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to discuss the static variables and arrays. So basically, when we define a function and when we call the function is going to execute certain blocks of code. And when the function is finished, whatever that has been done in the function is going to be removed from the memory. That we know from before. However, in order for the function to retain some part of the values that we initialized in another call, it is necessary to use static variables. Let me give you an example. So we would like to write a program that uses a static array to count how many times a function is called. So let's just eliminate the static part for the moment. We solve the problem using a normal situation, then we integrate the static variables. So we have one int main function here, and we have another function. It is called count calls, and it's a void type, and it passes no argument. This is why in the parentheses it's empty. So the first time we are calling this function starts to be executed. So we here initialize an array named call count, and it is of the integer type, and the value here shows that it only has one element and its element is 0. So it only has one element and that one element is 0. Okay. Then in order to manipulate different elements of an array, we can use the following code line, this one. So basically we are calling the array, and then we are calling the element of the array. When we are saying the 0, it means the first element, because C++ starts from 0. So if this array had two variables, two elements, for example, and we were writing 1 instead of 0 here, we were accessing the second element or the last element of the array. So here we can access the first element of array call count using this line. Okay, so now we learned how to access different elements of an array. So in order to access the first element of array call count, we are using this code, and by using plus plus, we are incrementing the first element of array call count. So previously it is defined to be 0. Now we are incrementing the first element of the call count array, therefore it should be 1 now. So we are adding one value to 0. So the first element now is 0. Then it is saying that function called, and it is going to print the first element of the array. Previously, we know when we wanted to print different elements of an array, like all the elements of an array, we used to use a for loop. So we were iterating over all the elements of an array. However, if we would like to access and print maybe or manipulate specific element of an array, simply we can use this. So because now we are writing C out, it's going to print the first element of the array called count. Here we are manipulating the first element of the array called count by increasing it by one value. We could decrease it also. So there are different things that we can do. So then the function, then it is going to print the first element of the call count array. After this manipulation, we expect the printed number here would be 1 rather than 0. Why? Because we increased its value by 1 here. Then this function is finished. This function is executed and we come back here. So this line is also executed. We go to the next line. When we go to the next line, again, the function is initialized. The array is initialized to be the type of int. It is going to have one element and its element is 0. Then we are going to increase this first element of the array called count. So we are incrementing it by one value, and when we are printing it, it is going to show us again 1 and another round. So we are going to call the function again. We are doing the same thing. So we are going to print 3 numbers. 1, 1, 1. Let me just call the function and then start the program. Okay. Here we see that for the first time it is calling the function. It is declaring and initializing the array, and then it is incrementing the value of the array here. And then it is printing. So it is printing one function called one time. When we are calling the function again, it comes back here. It declares and initialize the array again. It is incrementing its first element and it is printing it. Okay. However, when it is finished, it is removing everything from the memory. This is why the next time we are just having the function called one time and then the third time. Let me print the also cout. I think it's nice to have this line, so it would be easier to see the increment impact. We are saying that function called before manipulation call count 0 and del. Okay, let me run. Okay, so every time that we call the function, it is initializing and declaring one array. Then we are printing its first element. So function called before manipulation, the element of the array, the first element of the array called count is printed, which is 0. Then we are increasing it. We are incrementing its value by 1. So the output then will be 1. When we are printing it again, it is 1. So we see that an increase of 1 time is done. When we finish execution of this function and we come back here, we go to next line, we are going to call the function again. Everything is going to start from 0 again. So every time that we call the function, everything starts from 0. We are reinitializing again the array, we are declaring it, we are printing its first element, then we are increasing the first element. However, if we use a static keyword here before the type of the array, when we run, you see, the first time we run, it is going to declare and initialize the array. So far, it's the same thing, but we see the output here. So we added only one keyword static here. When we are printing the function called before manipulation, it is printing 0, which makes sense because the first element is 0 here, so it is going to print 0. Then it is incrementing the first element of the call count array by 1, And then we are printing the first element of the call count array here. So we are saying function called one time. Then we come back here and we call the function again. When we are calling the function again, here we are printing that function called before manipulation for the second round is 1. You see the difference? So it could retrieve what the first element of the array was in the previous call. So it is not printing 0 again, it is printing 1, which was the value of the first element of the call count function after the manipulation using this line in the first call in this line. But here we are calling it for the second time. It is still remembering that we one time has done one modification on the first element, and the first element is 1 because we did one manipulation. So when we add the keyword static, the memory usage is different. So it remembers that we had already declared and initialized this array once, we manipulated once and incremented its first value from 0 to 1. Now it is printing its first value using this line which equals to 1. Then we are going to increment the first element of the call count array in the second call. Then we are going to print it. So when we are printing it, it says function called call count. So print the first element of the call count array. It is going to print 2. Why? Because it remembers that when we started it was 1, then we increased it by 1 and it is now 2. This code is executed. We go to the third line, and when we go to the third line here, we will see that it is again remembering what has been done in the first call and the second call of the function. Now it's the third call, and it is going to print function called before manipulation. It is printing the number 2, and then we are modifying it again. We are increasing its value by 1, and we are printing it again, and it says function called 3 times. So there are two things to remember from the calling the function and using static variables. So the first thing is that when we have the static variables included, the program remembers what has been done before, and it uses the same memory. This is why it is remembering it. When it is initializing an array of a static type, it is going to initialize it, and it's going to be there forever as long as we are using this function, and it's not going to declare and then delete the memory in the end. So when we are using the static, it is going to remember. When we are not using static, it is going to initialize it, and when the function ends, it's going to remove it from the memory. So when the first call is ending here, it is going to remove everything. This is why in the second call it's not remembering anything. This is the first thing to consider. And the second thing is that it is very useful to, for example, initialize an array using a static variable to have a counter, like mentioning, okay, I would like to declare a function. In that function, there is an array that is of a static int, and we know whenever we enter the function, we are going to manipulate one data, for example, here. And in the end of the program, when you have like 200 lines, you may need to call this function again and again. Using static variables will help you to understand how many times this function is called. So it could also help you to have a counter there, because it's going to remember previous calls. And finally, The same thing could be done using call by reference. So instead of using static int array, we could simply define some arguments here and pass these arguments using call by reference. Therefore, the function was going to originally use the arguments that are passed in the same place of the memory. It was going to access the same place of the memory and then do the modification directly using those arguments. However, in terms of memory usage, there are some differences between using a static array or like calling a function by reference. These topics are also very important in memory management that we are going to explain in this course, but in another section. So just keep that in mind. This can be done also by using a call by reference, for example. It's a bit different. How we do it? So basically we need to remove this static keyword and we are going to define some arguments here and we pass the arguments using this function and we have the and sign before the arguments to mention to give the program the sign that we are using call by reference. So this could be done by both ways, using static variables or call by reference, but in terms of memory usage, there are some differences between these two. However, those differences are going to be discussed in another section in the same course, in this course, but in another section about memory management. Just keep that in mind. We are going to dive into the details later on in this course. Thank you for watching. Hello everyone, welcome back to another video. In today's video, we are going to do one coding exercise using arrays and static variables. However, before going through that coding exercise, I'm going to give you a little bit of concept about one type of arrays. So we start in the int main function. These parts are commented, so this is for our coding exercise. We're going to discuss them later on this video. But here, something that I would like to mention is that we learned how to declare and initialize an array. So this is an array of size 5 with the type integer. And all of its elements are set to 0. So when I print the print of the elements, when I want to do that, I write a for loop. It starts from 0 up to 5. When I lower than 5, and then increment the value of I by 1 time in every iteration. And then we are printing the ith element of array in each round. So it's going to first, when I equals 0, it's going to print the first element of the array. Then it's going to print the second, the third, the fourth, and the fifth. So let me just run this code. Okay. So it is very straightforward. So far, we know already how to do this. We're printing all the elements of this array. And this array is of size 5 with 5 identical elements. So instead of writing the 0 everywhere here, we can simply write it once and saying that it's size 5 and we only write one element of it because the rest are identical. And let me run it again. Okay, we see that we are having the same results. So when we are writing and declaring and initializing an array with the same elements, when you write down the size and only one of the elements, it's going to perceive exactly like this. So this array, when it is declared and initialized, is the same as this array. Okay, but in order to have shorter codes, we are going to use this version of declaring it. So this is a point that I wanted to mention before we dive into the coding exercise. But something to mention is that only this is true when the elements are 0. Okay, when the elements are 0, you can simply use this way of declaring and initializing. So if the elements R1, it's not going to work. Let me run. Okay. So as you see here, it's not going to consider 0 for all the elements, but 1 for the first element and 0 for the remaining 4 elements. So by default, C++ compiler is considering 0 for the not declared elements, and for the other numbers you need to give it to it. So if I mention 3 also here, it's going to consider the first element to be 1, the second element to be 3, and the rest that are not declared here to be 0. So something to just keep that in mind. So if you're putting 0 here, it means that all the elements are 0, because you said that it's an array of size 5. You put 0, so it knows that all the elements are 0. However, if you put 1, 2, etc., it's going to consider 1 as the first element, 2 as the second element, and if you're only adding 2 of the elements, the remaining elements are considered to be 0 by default. So this is something to keep in mind while working with arrays. Okay, let's dive into the coding exercise. So we would like to write a program that maintains a static array to store scores of a game and updates them in each function call. So we have one main function here. For example, let me just explain the first 2 calls and then the rest. And simply we are calling a function called update scores, which is of void type, and it is getting one argument, and here we are just giving the argument as the scores, let's say, to the function. We are passing this argument to the function, and the function basically is initializing one array of type int and static with the size of 5, and all the elements are 0. And also, in order to keep track of position to update, we are initializing one integer of type static to 0. So basically the index is 0 and the size of the array is 5. So as long as we are entering and calling this function, so if the index is lower than 5, which is the size of the array, assign the value x, which was passed to the function as an argument, to that index of the array scores. What does it mean? So when I call the function for the first time using the argument 10, I call using argument 10. Okay, here I'm calling the function using argument 10. Here x equals 10 and index equals 0. Okay, so when index equals 0, we are basically here accessing the first element of the array, and the array is this. Let me write it the other way. So the array scores is having 5 elements and all of them are 0. Okay, so basically with this line, when index is 0, we are having the array scores equals to 10. Okay, so here we are calling the function with the argument of 10. So here this function is called with the argument of 10, therefore x equals 10, and initialized we initialized index to be 0, and we have the index 0, and when the index equals 0, using this line we are assigning the x variable or 10 to the first element of the array score. Why first element? Because index equals 0 and index is put in the, you know, in the file, in the brackets of the score. So it means that we are assigning 10 to be the first element of the score, and then we have the incremental value. It means that 10 is assigned to the first element of the array score. Then we are incrementing. When this assignment is done, then we are incrementing of the value of index by 1. So we are manipulating it. And if index is not lower than 5, it's going to print, okay, scoreboard is full. So because we can only insert 5 score into the scoreboard because the size of the array is 5. So basically what we are doing here is done. Then we are saying current scores. We have a for loop and we are printing all the elements of the scores. So we are going to call the function twice. Let me run the code and then explain further the code. Okay, great. So here we're calling the function with the argument of 10. 10 equals x. So initially all the elements of the array were 0. This is not the initial array. The initial array is this one. So initially everything was 0 and the index was 0. It says index lower than 5, it enters. It assigns 10 to the first element of the array score. Why first element? Because index is 0 and basically using this line we are accessing the first element. So when the first element is equal 10, this happens. So 10, instead of having the first element to be 0, we are having the first element to be 10. Okay, and everything is done here in this if condition, and we are printing the array here. So we say current score, we are printing all the elements of the array, and the code execution for this function is done. We come back to the main function, we go to the next line. When we call again the function using the argument of 20. So in this case, we are having call using argument 20, x therefore equals 20, index equals 1 this time, scores 1 equal 20. So this time we are calling the function using the argument 20. And since the array was initially initialized and declared using a static keyword, it remembers what has been done before. So it remembers that we did a manipulation to index. So index was earlier 0, but in the first call it became 1. Why? We incremented its value here by 1. So it says that now index lower than 5, yes, because 1 is lower than 5. And why not 0? Because this is a static index. Okay, so the first time it was 0, but because it is static, it remembers that in the first call we manipulate and modify the value of index from 0 to 1. Now it considers that index is 1. So 1 lower than 5, yes. Therefore, it is going to put and assign the value x, which is 20 in the second call. Which 20 is going to be assigned to the second element of the array score. Therefore, the second element of the array score is going to be 20. What was the first element? It was 10. Okay, so when the 20 is assigned to the second element of the array score. This part of the if condition is finished. Then we are printing again the current score. So when we start from 0, the first element of the score, we are printing it again for the second time because it's the second time we call the function. It is going to print 10 because already from before it remembers, right? It is a static variable that used to initialize and declare this array. The first element is 10. Now we have the second element equal to 20. Okay, in the first time we only had 10 here, and the second element was 0. But when we call the function for the second time, the second element is set to be 20. Okay, and then when the second element 20 is assigned to the second, when x equals 20 is assigned to the second element of the array score using this line, after this is done, we are going to increase the value of index one more time. So when the plus plus sign is after index, it means that x is going to be set to the index element of the array score, and when it's done, then the index is going to increase by one value. Okay, this simply means that when plus plus is after index. So let me just remove the plus plus so you see the difference. It's more tangible. Okay, so when we remove plus plus, we're calling the function using the argument 10. And initially, in the first call, index is equals 0. So 0 lower than 5, yes. It is going to put 10 as the first element of the array score because index is 0. And then it's going to print all the elements of the array score. Therefore, it's going to print this one. And everything is done. We are going to call the function the second time, and we are going to call it using the argument 20. So in this case, x equals 20. However, since we didn't increase the value of index in the previous call, index is still 0. So it says 0 lower than 5, yes. So it is going to now index equals 0. Therefore, it is going to assign 20 again to the first element of the array score because we didn't manipulate the score, the index value. It is 0. But when we are having the plus plus for the next round, it's going to be increased. Okay. Okay, great. So let me uncomment the other lines as well. So when I uncomment the other lines, we see that when the second call is finished, the third call is done using number 30, and 30 is going to be the third element because we are increasing the value of index one time at by 1 point at a time. So let me also analyze this. So basically it's going to be equal to 1. So now call using argument 30, x equals 30, index this time equals 2, scores 2 equals 30. Okay, so basically when we are putting the number 20 to be the second element of the score, afterwards we are increasing the value of index, so index will become 2 in the next round of call. So when the third round of call is done using the argument 30, index is 2, so it started from 0 and now it's 2, and therefore when it's 2, it's going to assign number 30 as to be set for the third element of the array score. and then it's going to print, and then again it's going to call the function again with the argument 40 and 50. So therefore the array is progressively uh, being modified until it reaches the last part. So when the array is already full, we run the code again. So you see here, when we reach to this part, the array is already got the numbers that we want, and the size is only 5. And we were counting the size, keep tracking of the updates using the index, if you remember. So in the last round, index equals 5, index equals 0 because it starts, index equals 4 because it starts from 0. So index equals 0, index equals 1, index equals 2, 3, and 4. When index equals 4, we have done 5 modifications. Okay, 0, 1, index equals 0, 1, 2, 3, and 4. So all the 5 elements of the array are updated because it's an array of size 5. So all the elements are updated. Therefore, when we are for example, calling the function here, call using argument, for example, 50, x equals 50, index equals 4, okay? Therefore, scores 4 equals 50. When this is done, using this line, after having the index equals 4 here, and 50 is assigned to the 5th element of the array score, then we increase the value of index one more time, so index becomes 5. When index becomes 5, in the 6th call of the function, index is 5. Therefore, it says that, okay, if index lower than 5, it's not going to enter and not going to pass this condition. Why? The reason is that 5 is not lower than 5. Therefore, it's going to print the else, which says scoreboard is full. And then it's going to print the full array for us. So it was a very good example of how static variable is useful and is going to help us to have what we have in the output to update progressively, for example, the array. If we didn't have the variable static, we couldn't have the output something like this. So you see that progressively everything is updated, and in the end we have an array with scoreboards. We have an array that is like a scoreboard, and it's storing all the elements that we want. However, if we were not having the static variables, things were different. So let me just remove to show you how it's going to work. Okay. So the way that it was going to work was like this when static variables was not there. So we are calling the function for the first time, for example. The value is 10. So we have an array of size 5. All the elements are 0. Then index is 0. Index is lower than 5. Yes, we are going to then assign number 10 to be the first element of the array score, and we are going to increase the value of index later afterwards, and then we are printing the array. Okay, everything is done. When we print the array and we reach to this point, whatever that is done and modification that is done in the function, it's going to be deleted. So now we are calling the function for the second time. Again, it is going to initialize an array from 0 again. Then it's going to initialize one int called index to be 0. Then it says that, okay, 0 lower than 5, yes. So put 20 for the first element of the array score, and then increase the value of index and print everything. So first of all, it's since we are not using the static variables, it is not going to remember that in the first round of the call for the function, we increase the value of index. Why? Because index is simply one int and it's not static. Because it is not a static, it's not going to remember what was the value in the previous call of the function for the index. So index is going to be reinitialized and redeclared in every single call that we have for the function. This is why 20 is stored here, 30 is stored here, 40, 50, and also 60 is stored here, because whenever one function call is finished, everything is removed from the memory, like nothing happened. And then we are calling the function again. Everything starts from the beginning again, and it's going to perform all of the tasks. And then when it's printing everything in the end of the function, it's going to remove all the memory again. So it's going to call the function for the third time, for the fourth time, etc. So this is why it is important to use static variables if we would like to see the progress of how everything works using an array. Thank you for watching. Please go ahead and do these codings yourself, because it's very important to do the coding yourself and get to those bugs and errors and start thinking of what went wrong. That is the point where you find your weaknesses and you're going to improve from there. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to do another coding exercises using static array. Okay, so far we learned how important it is to consider static array in certain situations. In this video, we are going to write a program that uses a static array to store user input values across multiple function calls. So to do that, we have the main function and then another function that we are going to call repeatedly during in our main function. So the name of the function is store user input. It's of the void type and its argument is an integer called value. So in order to call it for the first time, we call the function with the value 5. Here we are initializing and declaring a static array with the size of 3, and all of the elements are 0. And then we are initializing and declaring an index to be static and integers set to be 0 initially. So this is index is used to track where to store the next input. So in the first call, index equals 0. So when we are encountering this if condition, we say, okay, 0 lower than 3. If this is the case, set the value, which is the argument of this function, which is 5 in the first run, in the first call of the function. Set the value 5 as the first index of the user input array. After doing that, then increase the index by 1. So in the initial run, it's like this equals to 5. It means that set the value 5 to be the first element of the user input array, and then the final index will become 1. Initial index equals to 0. Why initial index equals to 0? Because we initialize it. And why the final index equals to 1? Because after we set the 5 to be the first element of the user input array in this line, we are having plus plus sign here. So when we are having the plus plus sign, it's going to increase the value of index by 1. So the final index after this line will be equal to 1. Then we are simply printing the value. Value is number 5 because this is the argument of the function, which is defined here, and then it is being simply printed here. So whatever the number is being assigned to the first element of the array is being printed here. So we know what has been passed and what has been inserted to the array, just for the sake of checking. Okay. Then we have this else part as well. If this index is not lower than 3, it's going to enter this else part. There it is printing array is full, so stored values, or it is going to print all the elements of the array using a for loop, and the for loop is going to start from 0 to 3, which is the size of the array, and it's going to print all the elements of the user input array. So when I equals 0, it's going to print the first element. When I equals 1, it's going to print the second element. When I equals, for example, to 2, it's going to print the last or the third value. So one time the first call of the function is now finished. The program is executed, so the program goes to the next line and it's going to call the function again with the argument of 10. So now value equals 10, but because we are using a static array and index, now the program remembers that we already called the function one time, and it remembers that we did some modification to the first element of this array and also to this index number. So now that it enters this function, it goes to this if condition here, but it is not considering index to be 0, but it is considering index to be 1 because it remembers that we did some modification in the previous call for this function. So this is why actually the static variables are useful. So initial index in this case equals 1, and basically it is saying user inputs 1 equals 10, and final index equals 2. So it basically says that, okay, the index now is 1 is lower than 3, that is true, so it is going to enter this part. When entering this part, it's going to assign the argument, which was 10 in our case, to be the second element of the user input array. Why second element? Because the index now is 1 and C++ starts from 0. So 0, when index is 0, we are talking about the first element. When index is 1, we are talking about the second element, okay? So it is going to assign 10 as to be the second element of the user input array. When this has been done, we are going to increase the value of index by 1, so the final index will be 2 again. Okay, and we are going to call the function for the third time. Now the initial index equals 2 because it is a static int index. It is declared to be a static int, so the program remembers the modification. And also because the array is a static, it remembers we modified its elements, so it's not going to start from 0 again. And now user inputs 2 equals 15 and final index will be 3. How come? Okay, let's see. So the initial index value is 2. 2 is lower than 3. It's going to enter. So the argument that is passed to this function is 15. Therefore, the value is 15. The int value is 15. So 15 is going to be assigned to the third element or the last element of the user input array, after which we are going to increase the value of index, which was 2 and now it's 3. Okay, and in the meantime we were always printing the values that were passed to this function. So now index equals 2, and when we finish the execution of this line, final index is 3. So when we call the function one more time with the argument 20, it is going to say 3, which is the final value of index. Is it lower than 3? No, it's not. When it's not going to execute this part of the code, and it goes directly to the else part, which is this part. So when it comes here, it is going to say array is full. Why it is full? Because the size of the array was 3 and we already had stored 3 values in it. Therefore, and 3 is not lower than 3, therefore it is not executing this part, and now we see that 3 values are stored in the array, as you see here, 5, 10 and 15, and the size is 3. So it says array is full and it is printing all the elements of the array here for us. So let me just run and see the result. Okay, great. So in the first call, the value stored is 5. So as we discussed, the first element of the user input was set to be 5 and the value stored was 5, and the second value was 10 and then 15. And when we are passing the 20, it is not printing the 20. Instead, it says array is full because it is entering this else part. And then we are printing all the elements of the array, which are 5, 10, and 15. So the only reason that with every call, the program remembers what we have done and knows that, okay, the elements are different values and the index is updated progressively, and also the array is updated progressively, is because we are using the static keyword here. So if we don't use the static keyword here, you will see the difference. So you will see that it is printing 5, 10, 15, and 20. Why? Previously, when we reached 20, we saw that it was mentioning that the array is full, but it is not saying that. Why? Because index is 0 when the first call is done. 0 lower than 3, okay, and 5 is assigned to the first element of the user input array. We are increasing the value of index, and so index equals 1, and it is printing the value just like here, okay? And when we are calling the function the second time using this number, it is forgetting everything about the index value and the user input array. Because we are not using static variables, it is not going to remember. So when the first call is done, everything executed, it is going to remove everything from the memory, so it's not going to remember. So if I try to simply just print the array in the end of this function, we will see the numbers are different. So when we are printing the array in the end, we see, okay, let me just put an and L, it's nicer. Okay. So when we are calling the function for the first time, this is 5. 5 is set to be the first element of the user input. Therefore, this line is printed, which is seen exactly here. And then we are having this print of the array. So the first element is 5, the other elements are still 0, and the program execution is finished. So then we are calling the function again with the number 10, So it is going to consider index is now again reinitialized to 0 because it is not a static. So 10 is assigned again to the first element of the index of the user input array, just like here, and just like here, you see here, and it is when we are printing the array, it is considering 10 to be the first element. The first reason is that index is again starting from 0, therefore it is assigning 10 to the 0. And the second reason is that it is reinitializing the array to be 0. So this array was 0, 0, 0 with 3 zeros element, not 5, 0, 0 like here. Why? Because it is not a static. But when it is a static, so let me just comment this line. When it is a static, in the first call, it is setting 5 to the first element of the array, and then we are printing the array here 500. When we are calling for the second time, it already remembers that the first element was 5 and n index was the final index was 1. Therefore, now 10 is going to be assigned to the second element because now index is 1 and it is not considering this line because it is a static. So it is going to assign 10 to the second element of the user input, and only the third value is remaining 0. In the third call, 15 is going to be assigned to the third element of the array user input. So this is how static actually variables work, and this is how good how good it is to use them in specific situations that we would like the program to remember previous calls for the function when we are using an array, for example, or an integer value. Thank you very much for watching. If you haven't had the chance to rate this course yet, we would appreciate it to rate this course, and it is also very important for us to give us constructive feedbacks based on which we can improve our future courses for future students. Thank you very much. Hello everyone, welcome back. In today's video, we are going to write a program that provides an array and sorts the array in ascending order. To do that, we need to include one predefined library in C++ that is called algorithm. So we include the algorithm to do the job for us. Initially, in the first step, we need to declare and define one array for ourselves with the elements that we want. It depends on what we want. It can be having like 2 elements, 5 elements, 10 elements. It depends on what we want to do. Then we are going to understand the size of the array. We learned previously how to compute the size, so we basically have the size of function in C++. This is a predefined keyword. So we divide the size of the array by the size of the first element of the array. So it is going to be something like if each element of the array is going to have 4 bytes. So the size of the array would be 1, 2, 3, 4, 5, 6. 6 times 4 bytes will be 24 divided by 4. So it is going, the answer will be 6, which is the size of the array. So which is true because 1, 2, 3, 4, 5, 6. We will see that we have the 6 elements in the array. So this way, with this formula, we are going to compute the size of the array. Then, in order to sort our array, we are going to use one predefined library function in C++ that is called sort, and within the parentheses there are 2 parts that we need to mention, and they are separated by a comma. So the first part would be the name of the array, And the second part would be name of the array plus the size of the array. So let me first compile and see how the result would be. Then we are going to analyze the code. Here also we are providing a for loop that we are starting from 0 and we are going up to the size of the array, and we are printing all elements of the array to see the sorted array. So as you see here, the array starts with 5 and finishes with 6. When I compile, okay, when I compile, we will see that 1, 2, 5, 5, 6, 9. So the array is now sorted. But why we need to define the sorted array using these line of code? So this is a predefined library in C++ that consists of two parts. The first part is the name of the array. The second part is the name of the array plus the size. So instead of the size, in this case, the calculated size would be 6 as we discussed. If we are going to, instead of the size, we type 3, it is going to sort only the first 3 elements of the array. Let's see. Okay, so the first 3 elements are originally 5 to 9. When we sort them, it is 259, and the rest of the array remains unsorted. So in order to sort the array, the full array, we need to type size here. But if we are going to only sort the array for the first 3 elements, simply just type 3. For simply just 4 first elements you would like to be sorted, so you just simply type 4 here. So it's okay, it depends on what you want to do. It was a very good example for us to learn how to use the sort function to easily sort our array in C++. Thank you for watching. Hello everyone, welcome back. Now we learned how to write a program that gives an array and sort the array in ascending order. Now we would like to declare and define an array and sort it in an ascending order. However, only, for example, the last 2 numbers or the last 3 numbers you would like it to be sorted. So previously we learned if we would like to make the sorting for the first 3 numbers, we, instead of size, we will just type 3, so it is going to sort the first 3 numbers. We see that, okay, 5 to 9 is now 259, and the rest are remaining the same. However, if we would like to sort only the last 3 numbers of an array, we add number 3 in the first part. It is going to simply sort the last 3 numbers for us. So now we see that the first 3 are staying the same, exactly identical, but the last three numbers are having a sorted value in ascending order. So if you need to sort an array from some part of it onward, you just put the number in the first part of the call function sort. And if you're going to sort the array for the first few elements instead of size, which sort the full elements for us, instead of this, you just put a number like 2, 3, 4. For example, if you put 4, it is going to sort the first 4 numbers of the array. Thank you for watching. Hello everyone, and welcome to another video. In today's video, we're going to learn how to write a program that provides an array and sort the array in the descending order. So previously we learned how to do it in ascending order. Now we're going to learn how to do it in ascending or in descending order. To do that, we already know how to define and declare an array. Then we calculate its size. And then in order to sort it, we still, in descending order, we still use the sort function that is predefined by the C++ library function, and we need to include the algorithm library. In the first part, we put the name of the array. In the second part, we are putting the name of the array plus the size of the array. And in the third part, meaning this part, we are going to use another library function of C++ that is called greater, and then int and two empty parentheses and one empty parenthesis. This would do by default the sorting for us in the descending order using a predefined C++ library. To check how it works, we will just compile and see. So please note that the array is 529156. Now I compile, and here I'm printing all the elements of the array. So we need to have a result of a sorted array in descending order now. Okay, great. So we are seeing the result. So in order to sort an array in the descending order, we can simply call the sort function. In the first part, we are calling the name of the array, then the name of the array plus the size. And in the third part, we are going to write down greater int, and this function is called using this keyword is going to call the function predefined function of the C++ to simply do the job for us and makes our life much easier. And then we're just printing out whatever that is in the array. So this way, using this line of code, we can easily sort the array in the descending order. And also, we learned to play with this number. So if I put numbers plus 4, if I put numbers plus 4, you will see that only the first 4 numbers are sorted in the descending order. So, and the rest are staying the same. So this is why when we want to sort the full array, we are using the size, because the size is going to give the number of all the elements of the array. So this element is having 6 elements. So size will be 6. So when numbers plus 6 means that the full array is going to be sorted in the descending order. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to write a program that reverses all the elements of an array. To do that, we need to first declare and define an array. We calculate its size, and we're going to simply call the reverse function that is a predefined function by C++, but we need to include the algorithm library. So when we call the reverse function, there are two elements to consider. The first one is the name of the array. The second one is the name of the array plus size. And simply there, after that, we are printing the array to see if it has done some changes or not. So let me just run the code. So the original array is 1, 2, 3, 4, 5. The reversed array is 5, 4, 3, 2, 1. So now, as you see, 1 is exchanged with 5, 2 is exchanged with 4, and 3 remain the same. So when we have the size here, it is going to reverse the full array for us. But if we put, for example, 4, it is going to reverse the first 4 elements of the array. So let's try. Okay, because we put 4 and not the size or 5, it is going to consider the first 4 elements of the array for the reverse. So 1 and 4 has been changed, their place has been changed, and 2 and 3 are exchanged. However, 5 is remaining the same, and the reason is that because we didn't include the full array. In order to include the full array, we just simply put the size. And if we are going to reverse the array for the first 2 elements, 3 elements, 4 elements, and 5 elements, that depends on us. You can simply just manually change this size and put the numbers, and then the code will go and reverse those elements of the array. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to do some coding exercises regarding the arrays. So we would like to write a program that inserts one array in the beginning of another array. So we need, this is our target array, so R2, and we would like to insert R1 in the beginning of the R2. So we first declare and define both arrays, we compute their corresponding size, and then we are going to declare one array, a third array with enough amount of size to that can contain both arrays. So if each one of them is having 3 elements, this new array needs to have at least six size, at least have the size for 6 elements. So by default, I just put it 10 to make sure we are above the number that we are targeting. So we declare an array, a third array with enough size to be able to include both arrays. To do that, so firstly, we would like now to fill this new array with the values of the first and second array. To do that, we copy all the elements of the array 1 to the third array. So we are going to iterate over all the elements of the first array. So in order to do that, we computed the size, and the size would be 3 here and also 3 here, okay? And we know how it works from previous lessons. So basically, we are going to write a for loop that starts from 0 and it goes up to 3. So as long as I lower than 3, it is going to iterate over this loop. So I start from 0, then I is incremented by another value in another iteration. In the last iteration, I is going to be equal to 2 because 2 is lower than the size, which is 3 now. Let me also just size 1 equals 3. So if I equals 3, it's not going to enter this loop because 3 is not lower than 3. Okay? So in the first round, it is going to enter this loop and it is going to assign the first element, which is 10, of the array 1 into the first element of the third array. And then increase the I. So I is now equal to 1. It is going to put the second element of the array 1. This is the array 1 to the second element of the third array. And finally, it is going to put the third element of the array 1, which is 30 here, as to be the third element of the third array. So after doing this, this array is copied in the third array. So now what we need to do is just to continue copying the rest of the elements, which are the elements of the array 2, into the combined array. So we would have a new array containing both uh, elements of both arrays, and the first array is going to start the array and the second array is going to continue, because we wanted to make sure we are defining an array, a new array, that inserts these 3 values in the beginning of this array. Okay, so now the first array is copied to the third array, and now we're going to copy the second array into the third array. So I still equals 0, I equals 1, and I equals 2, while size equals 3. Okay, size 2. Okay, now the first three elements of the third array is filled with the elements of the third array of the first array, sorry. Now, as of fourth element, we need to add the elements of the second array. As the fourth element of the third array, we're going to insert the elements of the second array. To do so, we need to iterate over all the elements of the second array, and it starts from 0, it goes up to 2 for the values of I, and the size 2 is calculated to be 3, which is calculated here. So now that we are inserting the elements, for example, when I equals 0, we are adding the first element of the second array to be the size 1 plus I element of the third array. But size 1 equals 3. So it means combined size 1 plus I, in this case, in the case where I equals 1, I equals 0, it is going to replace these numbers plus it equals R2. Okay, so in this case, it is going to put, because I equals 0, it is going to put the first element of the second array to be the fourth element of the third array. Why fourth element? Because the first three elements were already filled with the previous array. Now here I equals 0 and size 1 equals 3, so it is going to right away start with the fourth element. We know in C++ we start from 0, so when the size is 0, it means the first element, and when it is 3, it means that it's the fourth element. So the fourth element of the combined array is filled with the first element of the second array, and when I equals 1, we will have something like 3 plus 1 equals so in this case, it is going to put the second element of the R2 as to be the fifth element of the array combined. And finally, when I equals 2, it is going to simply put the third element of the second array to be the sixth element of the third array. So basically, after this loop, the combined array will look like this. Combined array is having 10 elements because we initialized it to be this way. It looks like before this loop, let me just also, before this loop, it was looking like this, meaning that all the elements of the array were 0. Now all the elements, we could also, for example, we could do something like this to make sure that it works, okay? Or we can also eliminate that. So then we can, what we can do is to, yeah, where was I? Yeah, I was here. So before doing any changes, all the elements of the array were equal to 0. Now, what we did using the first loop, we inserted all the elements of the first array in the third array. So the third array looks like this now, and the rest of the elements are 0. And after this loop, this array looks like this, as you see here. So here we are having a new array with 10 with the size of 10 with the elements of the first array and the second array. Basically, this is the element, these are the elements of the second array. Basically, we inserted the first array in the beginning of the second array, which was our target. So in order to print these values, we can simply write a for loop that is iterating over all the elements of the array combined. So I is going to go until the size of the combined size of two elements, or simply just the size of the third array. It's not important. When we put this size 1 plus size 2 here, it is going to print only the first 6 elements of the combined array. Let's see. Okay, great. As we see here, it is now having the first element, the first 3 elements, all the elements of the first array, and then all the elements of the second array. So this way we can insert an array in the beginning of another array. It is very straightforward, just you need to be careful about the second loop, that you put the size 1 plus I here, so it is going to insert the first element of the second array as the fourth element of the third array if each array is having 3 numbers, because the first 3 are already filled. So basically, a general formula would be to start from the size 1, like the size of the first inserted element plus I. So, and here we will have the ith element of the array 2 to be set to the size of the first element plus I to be set for the third array. So if here it was like 4 elements, still that formula would work because size 1 equals 4. So this is the only thing that we need to be careful about, and this way we can insert an array in the beginning of another array. Thank you for watching. Hello everyone, welcome back. In the previous lecture, we learned how to insert one array in the beginning of another array. So initially we defined 2 arrays, and then we initialized a third array, and the third array was going to in fact merge these 2 arrays. So we were having like this target array, and the first array was being inserted in the beginning of the second array. However, after discussing this lecture, although we are able to know how to insert an array in the beginning of another array, but we could see it also the other way around. So what if we would like to insert an array in the end of another array? So in this example, we had this array R2, that R1 was inserted in the beginning of this array. Seeing it the other way around, we could mention that the array 2 like to be inserted at the end of the array 1. So this example can be very helpful for doing both tasks. So you can either mention that write a program that inserts one array in the beginning of another array, meaning that array 1 is inserted in the beginning of array 2, or we could write a program that insert array 2 at the end of array 1, because when I run the program, we see the resulting array is 10, 20, 30, the first array, then 40, 50, 60, the second array. We could either say the first array is inserted in the beginning of the second array, or the second array is inserted at the end of the first array. So both of them are the same. It depends what we are going to do with the program. This video is just to show you we could see things differently for one specific coding task. In the next video, you will learn how to insert one array in the middle of another array. Thank you for watching. Hello everyone, welcome to another coding exercise session. Today we would like to write a program that insert one array in the middle of the second array. So this is our first array, this is our second array, and we would like to write a program that inserts the first array in the middle of the second array. Okay, to do that, we declare two arrays. The first one is 120, the first array is 10, 20, 30, and the second one is 40, 50, 60, 70. And we are computing the size of two arrays. We are initializing one new array that is called combine. We call it third array. And in order to find the middle point of the second array, we divide the size of the second array by 2. So this will give us the middle point. In this case, it has a size of 4. When it is divided by 2, it is going to give us number 2. So after this number, we're going to fill these parts you are going to copy these two elements in the third array. So let's begin. So here we are computing the middle point, like we are having 4 elements here. 4 divided by 2 will be 2. So middle equals 2, I equals 0, I equals 1. Okay, these are the scenarios. We iterate over the second array. We start from 0 and we go until I is lower than middle, which is 2 here. So I is going to get two values, so 0 and 1. It is therefore is going to perform 2 iterations. In the first iteration, when I equals 0, we will have the combined 0 equals r2 0. Basically, it is assigning the first element of the second array to be the first element of the third array, meaning that 40 is going to be assigned as the first element of the array combined. Then in the second iteration, combined 1 equals r2. It means that the second element of the second array, which is 50, is going to be assigned to be the second element of the third array. So now if we print our third array, it is going to have these two values, 40 and 50. So basically our third array is holding, after this loop, is holding 40 and 50. And the goal is to insert the first array in the middle of the second array. So now the 40 and 50 is there. Now we need to copy 10, 20, and 30 here, and then copy 60 and 70 here. So now we are going to iterate over the first array. To do so, we are having one iteration here. So the size 1 equals 3, and there are scenarios where I equals 0, I equals 1, and I equals 2. So I starts from 0 and it is going to continue until it is lower than size 1, which is 3. So it is going to have values 0, 1, and 2. When I equals 0, we are basically having the middle size plus 0 equals r1 0. So basically in this line, the first element of the first array, which is 10, is going to be inserted as the third element of the third array, which is combined. So now combined, previously combined was look something like this. After the first iteration of this part of the code, it is being equal to 10 as well. So 10 is added to the first element, to the as to be the third element, sorry. Then we are having here combined 2 plus 1 equals R1 first element. So the second element of the R1 now is assigned to be the fourth element of the combined array. So it is going to put 20 here, and we know when the sum of this part is 3, it means the fourth element, because in C++ we start from 0. So the index, this one is 0, 1, 2, 3. So when the index is 3, it means the fourth element. And in the last iteration, we have combined 2 plus 2 equals this equation, meaning that the third element of the first array, which is 30, is going to be assigned to be the fifth element of the third array combined. After this execution, our combined array looks like this. It is having 40, 50, so the first two elements of the second array, and then it is having all the elements of the first array, and we need to insert the last two elements of the second array as well. To do that, we need to write another for loops, and here we know middle equals 2 and size 2 equals 3. Okay, so size 2 equals 4. Yeah, because in the second array we have 4 elements. So having said that, I is going to start from 2 and it is going to go until 4. So when I equals 2 and when I equals 3, these are the only two situations where I is going to get some values, because I equals 2 is lower than size 2, which is 4, and when it is 3, it is still lower than size 2, which is 4. So I starts from to be 2. When I equals 2, we will have something like size 1 equals 3 plus 2, and something like this. So it is going to assign the third element of the array 2, which is 60, to be the sixth element of the third array combined. It means that combine will look like this. So already it was having 40, 50, 10, 20, and 30. Now we are adding the sixth element to be the third element of the second array. So 60 is going to be here. And then when I equals 3, we will have the formula something like this. R2, okay, it means the fourth element of the second array must be assigned to be the seventh element of the combined array, which means that the 70, the fourth element of the second array, 70, is going to be assigned as the seventh element of the array combined. So basically, after the third loop, we are having the combined array, or the third array, looking something like this. And now here we are just printing out the combined array. Let me compile. Okay. As we see here, our new array is having the first two elements here, then all the elements of the first array, and then the rest of the elements of the second array. So basically, in this lecture, we learned how to insert one array in the middle of the another array. Thank you for watching. Hello everyone, welcome back. So far, we learned how to declare and how to define an array like this. For example, this array is named config, it is of integer type, and it has three elements, 10, 20, and 30. And we learned that we can modify different elements of the array. For example, here we are changing the second element of the array, which is 20, to be 25. And then we are printing the modified array like this. So let me just run and see how it works. Okay, as we see here, the original array was 10, 20, 30, but we modified the second element and we replaced it with 25, and now we are having 10, 25, and 30. So we basically know how to modify one element of the array. But there are some times that we may make mistakes throughout our code, our different blocks of codes in the program, that unintentionally we change one element of the array, but we didn't want to do that. In order to avoid any modification for elements of the array, we can use the constant array. So a constant array is declared as to be constant, so all the elements of the array are constant. It means that it is not allowed to modify any elements of the array after initialization. To do that, we can simply use this keyword, constant array. So this way, this array cannot be modified anywhere throughout the code. And as you see here, there is an error because it says we have a constant array that is being modified here. Therefore, it returns an error. So when we have a constant array, it is not possible to modify it throughout the code. So in case you are using an array and for any reason you would like it to be constant and not to be modified unintentionally, for example, throughout different blocks of code, you are advised to use the constant keyword, so const, in order to keep everything safe and not allow the modification. Now, when we compile, basically we get the original value for the array, and the reason is that we remove the modification part. And when I uncomment the modification part, you see that this returns one warning here saying that variable config declared constant here. It's a warning, and there is an error saying that it is of type constant and you are trying to modify it, so it is not possible. So this is a very good way to keep everything as it is and to keep everything safe if you would like not to allow C++ to let you modify your array throughout your code. Thank you for watching. Hello everyone, welcome back to another lecture. In today's lecture, we are going to discuss two-dimensional arrays. So far, we learned about one-dimensional array, and now when we would like to store our data in a matrix or a table, we need to use two-dimensional arrays. In order to do that, let's review what we learned so far about arrays. Here, we are declaring one array that is named myArray. It's of integer type, and there are three elements in this array, and the elements are 1, 1, and 1. This value 3 is the number of elements, but also the number of columns that we can see in this array. So this is the first column, this is the second column, and this is the third column. However, because there is only one row here, we didn't declare the number of rows here. An example of a two-dimensional array would be this array. So we would like to write a program that stores 3 by 3 matrix of integers and print its value. In order to do that, it means that we are going to have 3 rows like this and 3 columns like this. So the first number corresponds to the number of rows and the second number corresponds to the number of columns. And here it's the name of the name of the array, that is matrix, and here it's the type of the array, which is of type integer here. So in order to declare a one-dimensional array, we only type number of columns, but here in order to have a two-dimensional array, for example, first we declare the number of rows and then we declare the number of columns. In order to print a two-dimensional array, we know that we need to use for loops. In order to have a for loop that could do the printing of different rows and columns, we need to use nested loops. Basically, nested loops are used when we have an outer loop and an inner loop. So the outer loop is going to count the number of rows, and the inner loop is going to count the number of columns. For example, here we are sending the message saying that the matrix is, and in the outer loop, this one is the outer loop. Outer loop starts from I equals to 0, I lower than 3, I plus plus, and then we have the inner loop here that corresponds to columns. J starts from 0, J lower than 3, J plus plus, and we are going to print matrix, which is the name of our two-dimensional array, row I, column J. To do that, let's see how it works. So initially I equals 0 when the outer loop is performed, and the inner loop J equals 0 as well. So it is going to print matrix 0, 0, meaning that the value that corresponds to the first row and the first column, which is 1. So it is going to print 1. Then I still equals 0, but j is increased by 1 value because we are still in this loop. This loop is going to continue until j is not lower than 3 and does not pass this condition anymore. Then we are going to the outer loop to increase the value of I from 0 to 1. So now I equals still 0 and j equals 1. So we are printing matrix 0, 1, which equals to first row and the second column, which is 2. And then I equals 0, j equals 2, j is increased by another value, 2 is lower than 3, so we still are in the inner loop, and we are going to print matrix 0, 2. This happens to be the first row, which is this place, and the third column, which is this number, so 3. So now that j equals 2, if we increase the value of j by another one value, j will be equal to 3. So 3 is not lower than 3, so it does not pass this condition and it cannot enter the inner loop another round. When this loop is finished, we are going to go to the next line using cout and del. Then we go up again, and now the value of I from 0 has increased to 1. Now I equals to 1, j again equals to 0, because now with the I equals 1, we enter this inner loop, and j is going to, while I equals 1, j is going to take the values of 0, 1, and 2 again. So now we are printing matrix 1, 0, which means the second row, which is this part, and the first column. So the first column would be second row, and the first column would be 4. Then I still equals 1, j equals 1 now. We have matrix 1, 1, meaning that the second row, the second column, the number corresponds to 5. Then I equals 1, j equals 2. We have the matrix of 1 and 2. This means that we are going to discuss the second row and the third column, which corresponds to value 6 here. And finally, when j again reaches its maximum number, it is going to go to the next line using the cout and del, and then I value is going to increase from 1 to 2. So 2 is lower than 3. So this is the last time that we are entering this outer loop, because the next time I equals 3 and 3 is not lower than 3 and it does not pass this condition in the parentheses. So this is the last time I equals 2, j equals 0, matrix 2, 0, and this would equal to the third row and the first column. So the third row, which is this line, and the first column would correspond to number 7. Then we have I equals 2, j equals 1. We are going to print matrix 2 and 1. So the third row and the second column corresponding to number 8, I equals 2 and j equals 2, matrix 2 and 2. So it is going to print the third row, and the third column corresponding to the value of 9. So now we learned how to print this two-dimensional array. Let me run the code and see how it works. Okay, great. So we see that here we initialized a two-dimensional array, and then we started going through this two-dimensional array that is called matrix row by row. So in the first row, when I equals 0, we iterate over j from 0 to 2. So we're printing values 1, 2, and 3. Then we go to the next line where I has increased by another value, and then we are printing 4, 5, and 6. Then we go to the next line and I has increased again by another value, so I equals 2 now, and we are printing 7, 8, and 9. So using this coding exercise, we not only learned how to declare and define a two-dimensional array, but we had the chance to review the nested loops and show how using nested loops we can print a two-dimensional array, and also how we go through the iteration of an outer loop and an inner loop in nested loops. Thank you for watching. Hello everyone, welcome to another coding exercise session. In today's lecture, we are going to write a program that stores two 2x2 matrices and calculates their sum. In order to do that, we first declare and initialize our first matrix that is called matrix 1. So it's a 2x2 matrix, And in the first row, there are two values. In the second row, there are two values. So there are basically two rows as it is shown here, and there are two columns as it is shown here. So then we have another 2 by 2 matrix, uh, which corresponds to this one. We have 5, 6 in the first row and 7, 8 in the second row. Finally, we have a third matrix that is also 2 by 2 matrix. So it's a 2 rows and 2 columns matrix that is going to store the sum of the second and the first two-dimensional arrays for us. In order to calculate the amount that we need to put in the third matrix, we need to know how to make the summation between two matrices. So in order to do that, we first need to know, so this number, the first row, first column of the first matrix is going to be added with the first row and the first column of the second matrix, and it is going to be in the first row and the first column of the third matrix. So imagine that we have now a matrix that corresponds to our third matrix here. So this number, which is the first row and the first column of the third matrix, which is sum, has to be 6, which is the sum of 5 and 1. Okay, so by adding the first row, first row and column of the second matrix and first row and column of the first matrix, we are going to build the first row and column of the third matrix. So then the first row, second column of the sum matrix is going to be 6 plus 2. Why? Because it corresponds to the value of first row, second column of the second matrix and the first row, second column of the first matrix. So it is going to be 8. The same policy goes with the second row, first column number and the second row, second column, which is 8 plus 4 coming from this 4 and this 8, which means that it needs to be 12. So this is the sum of these two-dimensional arrays. However, in order to do it in C++, what we need to do is to iterate over both matrices and set and assign the summation of each number to the third array. In order to do that, we need a nested loop. So a nested loop starts from 0, goes until I is lower than 2, and j starts from 0 until j is lower than 2. So basically, firstly, I equals 0, j equals 0. In this case, the first row and the first column of the sum matrix is going to be equal to matrix 1 and matrix 2. So basically when I equals 0 and j equals 0, therefore the first row and the first column of the sum matrix will be equal to the first row and the first column of the first matrix, which is 1 now, and the first row and the first column of the second matrix, which is 5 now. Therefore, the value will be 6. Okay? Then still I equals 0, j equals 1, so we will have the first row, second column of matrix sum equals to the sum of the first row second column of matrix 1, and again the first row, second column of the matrix 2, which means that number 2 plus 6, which is here, so this equals 8. Here also we had 1 plus 5 equals 6. Then j, because in the last iteration I equaled 0 and j equals 1. Now j, if j is increased by another one value, j equals 2, so 2 is not lower than 2 is not lower than 2, so it's not going to enter another time in this inner loop. And therefore this inner loop has done one full iteration, so it is going to go up again and increase the value of I by another value. So I now equals 1 and j equals 0. So we are going to have this here. Let me just type it down first. So it will be okay. So now I equals 1, meaning that we are discussing the second rows, and j equals 0, it means that we are discussing the first column. So second rows, first column, second rows, first column, second row, and first column. So the second row and first column of the third array, which is sum, equals to the second row and the first column of the first array plus the second row and the first column of the second array, which is 7, which equals 10, which we have here. Then I equals 1, j equals 1, so we have the sum 1 1, matrix 1 1 1 plus matrix 2 1 1. So this means that we are now talking about the second row, second column, so this number 12. Now this 12 number is calculated based on the second row and the second column of the second matrix, which is 8, and the second row and the second column of the matrix 1, which is 4. So it will be 4 plus 8, it's equal 12. This way we are assigning numbers to the matrix sum, and then we are simply just print the values that are assigned to the sum matrix here. So in order to do that, we have another nested loop. The outer loop iterates the number of rows, which is 0 and 1, so we have 2 rows, and j inner loop is going to iterate for the columns, so j will get the value 0 and 1, so there are 2 columns. So let me run and see. Okay, great. So basically we see that the sum of 1 and 5 equals 6 here, that is printed here. The sum of 2 and 6 equals 8, that is printed here and here. So 3 plus 7 equals 10, which we have, and 4 plus 8 equals 12, which we have here, and we wrote the details 6, 8, 10, 12 here as well. And here we're just printing the matrix. So in this lesson, we learned how to declare two-dimensional arrays that are having 2 rows and 2 columns and how to calculate their sum. We analyzed a nested loop here that is assigning the values uh, based on the summation of the first matrix and the second matrix, row by row, column by column, to the third matrix, which is the sum. And then we learned how to print the final matrix that is called sum. Thank you for watching. Hello everyone, welcome back. In this lecture, we are doing a coding exercise regarding two-dimensional arrays. So we would like to write a program that stores marks of 3 students in 4 subjects and calculate their average mark. So when we have 3 students, it means that we are having 3 rows, and each row is corresponding to different marks in different subjects. So we are having 4 subjects, like 4 rows here. So the first row, first subject, means the first subject of the student 1, the second subject of the student 1, third subject of the student 1, and the fourth subject of the student 1. Second row corresponds to the student's 2 mark from the first subject to fourth subject, and third row corresponds to the third student from the first subject to the fourth subject. So this is the uh, matrix or two-dimensional array that we have here of integer type, and there are 3 rows here, as you see, and there are 4 columns here, as you see it here. So this is the declaration and definition, and we would like to calculate the average mark of the first student, then the average mark of the second student, and then the average mark of the third student. In order to do that, we are going to use a nested loop, because we learned if we are going to iterate over the data of a matrix or a two-dimensional array, we need a nested loop. The outer loop will work as we are iterating over the rows, and the inner loop works like we are going through the different columns here. So we have 3 rows starting from 0. We are going to have the first row, second row, and the third row. So I is going to get value between 0, 1, and 2. So 3 rows. Then we are having the inner loop, which is starting from 0 going to until j is lower than 4, meaning that it's going to get value of 0, 1, 2, and 3, meaning that there are 4 subjects. After the outer loop, we are initializing and declaring an integer called sum, where we are going to store the marks of each students individually. For example, so when we start I equals 0, meaning that meaning that we are discussing the first student. So, and j equals to 0, it is going to put the sum will be equal to sum plus marks 0 and 0. It means that sum equals 0, because initially it was 0, plus the first row and the first column, meaning that the first subject of the first student. So it is 85. Okay, so the sum equals 85. Then I still equals 0, meaning that we're still iterating over the marks of student 1. However, we are going to discuss the second subject of the student 1. It means that sum equals sum plus marks 0 and 1. It means that sum equals already from the previous iteration, we calculated the value of sum, so it was 85. So here it is not 0 anymore, it is 85, plus the first row and the second column of the matrix marks, which is the first row and the second column, first row and the second column of the matrix marks, which is 90. And doing the math, we see that 90 plus 85 will lead to having a sum equals 175. And then we are having I equals 0, still discussing student 1, j equals 2, sum equals sum plus marks 0 and 2. It means that sum equals 175 that we calculated in the previous round, plus the first row and the third element. So first row and the third element of the matrix marks, which is 78. So by adding this, we get to the number of 253. And finally, here I equals 0, student 1 still, j equals 3, so sum equals sum plus marks 0 and 3 means that sum equals 253, which is calculated in the previous round, and the first row and the fourth column, first row and the fourth column, which is 92, is calculated here. So 92 will lead to have the overall sum of 345. So at the end of the inner loop that j equals 3, here we saw that the value of sum equals 345. Now the inner loop is finished, because if j is increased by another value, j will be equal to 4, and 4 is not lower than 4. Therefore, it does not pass this condition. Therefore, it's not going to enter this inner loop one more time. So now the value of sum is calculated to be 345. This inner loop is finished, but before going up to increase the value of I by another time, by another one value, we are going to calculate the average of the student 1. So we're printing average mark of a student 1 equals sum divided by 4. And why 4? Because there are 4 subjects. So it is going to print the average of the first student. When it is printing the average of the first student, it is going up. Now it increased the value of I by 1. So I equals 1, meaning that we are calculating the second student marks, and j equals 0. Then again, I equals 1, student 2, j equals 1, etc. until j equals 3. Then we calculate the average of the second student, and then we again increase the value from 1 to 2, meaning that we are discussing the third student. So j starts from 0 and goes until it is 3. Here again goes until it is 3. So then we are calculating the average of the third student as well. So let me compile. Okay, great. So here we saw that the average mark of the student 1 is 86.25. The second student is 84.75, and the last student is 89.5. So we learned that this is a declaration of a two-dimensional array or a matrix that has 3 students, each are having 4 subject marks. we iterated over each student. The outer loop is for rows and the inner loop is for columns. We calculate the sum of each row corresponding to each student marks. When we had the summation here in the end, we calculated, we divide the sum by 4 because there are 4 subjects here, and we print the average of the first student. Then the inner loop is finished. The inner loop is finished. The value of we go up again and we increase the value of I by 1 value. So I previously it was equals to 0, now it is equal to 1. 1 lower than 3, yes, enters. It reinitialized the sum equals to be 0. So now it is 0. We are concerning the solution for the second student. It is 0. We're starting from 0 again. And then j goes from 0 to 3 and storing the sum of the 4 marks of the second student, then calculating the average here again, and the same again goes for the last student. So it was a very good example to learn how to work with a two-dimensional array and how to calculate the average of each row. In an example, we calculated the average of marks of 3 students, but basically we were calculating the average of each row. So as you see, it is very useful and it is very nice to use C++ to do that for us. So if you have some time, please go ahead and do some practices. Do this practice several times, the very same practice several times. So you will get used to the syntaxes, and also you will get used to finding where the errors come from, so you can improve from there. And in case you haven't had the chance to rate this course yet, please go ahead and do it, because it would be beneficial for us and other people can recognize this course if you find it valuable. And also, we would appreciate if you give us some constructive feedbacks on this course. It will help us to provide a better course in the future for future students. Thank you for watching. Hello everyone, welcome back. In today's lecture, we are going to discuss multidimensional arrays beyond 2 dimensions. So we would like to write a program to store sales data of 3 departments, each selling 4 products over 5 months. And we are going to display sales of one specific product across all departments and months. So this information, 3 department, 4 product, and 5 months, show that we need a 3-dimensional array. And the array needs to be something like this. So the dimensions are like department, product, and month. To do that, we initialize the array. In order to initialize and declare a 3-dimensional array, this is the name of the array, this is of the type of the array, and we see here there are 3 dimensions. The first dimension is for the number of department. The second dimension is the number of products, and the third dimension is for the months. So here we see that the first department is discussed here in this part, then it is separated by a comma. Another department, the second department, is discussed here, they separated with a comma from the third department. So this is the first dimension. The second dimension is the number of products, that are 4. Therefore, we are going to have, in each department, we are going to have 4 rows. Each row is representing one product. So again, here we are having 4 rows. So here is also product 1, here also product 2, product 3, and product 4. And also in the last one, we are having the same thing, product sorry, product 1, product 3, product 2, and finally product 4. So we are having 3 departments like this. You see here, each of them are having 4 products, each one representing a row. So you see each department matrix is having 4 rows, and also each department is having 5 columns, meaning that product 1, first month, product 1, second month, product 1, third month, etc. Then we have, for example, product 2 from month 1 until month 5. So this one, for example, represents the data of the department 1, product 4, and the 4th month. This is how we navigate through the initialized matrix. Now, when we initialize this matrix, we would like to display, for example, the sales of the product 2 over 5 months across all 3 departments. Okay, to do that, we mentioned that the product, we initialize and declare one integer called product equal to 1, because it's based on the 0 indexing for each product, and we are mentioning that, okay, sales for product, so it is already 1. When it is added to 1, it is going to print the number 2, which is the product 2 that we are going to iterate over. Okay, then in order to print values in a in a matrix or in arrays, we need nested loops. So here we are iterating through different departments. This is the outer loop, and this is the inner loop. So the outer loop is iterating over all the departments starting from 0 until the depth is lower than 3, because it will be 0, 1, and 2, meaning that there are 3 departments. And then it is printing the value of the department plus 1. Why plus 1? Because it is a 0 based index. So when initially the value of the depth equals 0, so 0 means we don't have department 0. We have 0 plus 1, it will show the department 1, then 1 plus 1 department 2, and 2 plus 1 department 3. And then we enter the inner loop that iterates through the months. So months, we mentioned that we have 5 columns and we are having 5 months. Okay, here we are also having it. Therefore, it is going to start from 0 until month is lower than 5, meaning that it is going to get the value 0, 1, 2, 3, 4. It means that there are 5 months. And then it is going to print the index of the month. For example, when month equals 0, 0 plus 1 means that the first month is printed. And when the first month is printed, we are going to have the matrix of called sales. The first department, let me just analyze the code here. So depth equals 0, product equals 2 equals 1, sorry, because it shows the second product. And then we have the month equals 0. So basically, when we reach here in the first iteration, we are having these values, and when having these values, it means that we are going to have the matrix of sales in the first department, second product, and the first month. Then still dep equals 0, product equals 1, month equals 1, sales will be 0, 1, 1. So it is going to get the value of the matrix sales, the first department, second product, and the second month. So this value corresponds to the first department, second product, first department, second product, and then the index of month is 0, meaning that the first month. So it is going to print 20. Here it is going to first department, second product, and the second month, means that it is going to print the value 22. And then it is going to continue until dep equals 0, product equals 1, and month equals 4, and it is going to print the value of the first department, second product, and month 5, which is 28. After this has been done, so the inner loop has gone through all the months from 0 to 4. From 0 it starts and ends to 4. And then it is going, now it's the time to increase the value of the depth. So now depth is equal to 1. Still product equals to 1 because only the second product is being discussed, and month equals 0 to 4 again, and then we go for the depth equals 2, product equals 1, and month equals 0 to 4. So this way we are iterating over all the departments and all the months of the second product. So we are basically printing all the values of the second product over 5 months in 3 departments. Okay. So now let me run the code and see how it works. Okay. So as we see here, we have the first department, second product over 5 months. So it is 20, 22, 24, 26, 28, 20, 22, 24, 26, 28, and this is the first department. Then we have the second department, exactly like the second product, and we have the third department as well, which equals to the third department here. So this is how we are obtaining the data. Now, as we see here, we are having a nested loop consisting of 2 for loops. If we were going to iterate over all the products, we should have had 3 loops there. So 1 outer loop, 1 middle loop, and 1 inner loop to go through the departments, then products, and then months. But because the products was a constant here and we were only wanted the data for the second product, we consider it to be one integer value always equals to 1. This is why we don't have 3 for loops here. And this is very practical example. Please go ahead and do the exercise yourself, because for example, if you're in a sales department and you're doing some data scientist works, for example, you need to call all the data and store it somewhere to do some statistical methodology on the data. For example, this is how we can do it in C++, for example. So please go ahead and do the coding yourself. It is very important to get to know to the shape of the multidimensional arrays and how they work. And we could have, for example, a 4-dimensional array, adding one layer of complexity, for example, department, product, month, and then we could say store. So there are, for example, 2 stores, each consisting of 3 departments, and each department we're having 4 products over 5 months, for example. This is another layer of complexity. As you see, we can have multi-dimensional arrays to store data, complex data for us to be able to organize our data in a database. Thank you for watching.